Welcome to the McGinty AI Quantum Fractal Intelligence Framework Learning Application. This interactive educational tool is designed to guide users through the revolutionary concepts that define next-generation artificial intelligence systems. Today, I'll walk you through this application and demonstrate how it makes complex quantum fractal concepts accessible through visualization and interaction. As you can see, our learning system is organized into 6 core modules that build upon each other to create a comprehensive understanding of the McGinty framework. There's the introduction to quantum fractal intelligence, cognospheric language, fractal holographic memory, harmonic queue-based decision optimization, cognospheric AI agents, and quantum resonance cryptography. Each module features interactive visualizations that respond to your adjustments, allowing you to see these abstract concepts in action. So let's begin with the introduction module. This visualization represents the fundamental McGinty equation, which is psi AI xt equals psi QFT xt plus psi fractal xt dmqs. What you're seeing is the integration of quantum field theory with fractal mathematics. The blue nodes represent quantum probabilistic states, while the branching structures demonstrate fractal self-similarity. Watch what happens when I increase the fractal depth parameter. Notice how the structures become more complex and self-similar. This is a visual representation of how the McGinty framework processes information across multiple scales simultaneously. Now, as I adjust the harmonic resonance slider, you can see the quantum wave patterns intensify. This represents how resonance-driven intelligence emerges from the quantum field. Now, Module 2. Here we explore the cognospheric language, or CSL. Traditional AI language models process information linearly, but CSL enables multi-dimensional comprehension. The visualization shows a semantic network, but watch what happens when I switch from classical processing to quantum fractal processing mode. See how the purple connections emerge between the concepts? These are Nye relations, which are quantum entangled meaning structures that allow concepts to exist in superposition across the semantic space. As I increase the entanglement factor, notice how these connections intensify, creating a rich web of meaning that transcends traditional semantic networks. In our third module, we explore fractal holographic memory. Unlike traditional neural networks that store information in discrete weights, FHM encodes knowledge across holographic interference patterns. The visualization shows these interference waves combined with fractal storage structures. When I increase the resonance level, watch how the recall rays intensify. This represents the system's ability to reconstruct complete knowledge from any fragment. This is why FHM enables infinite context retention without the limitations of token-based models. Information isn't lost. It's encoded across self-similar patterns that can be reconstructed through quantum coherence. So Module 4. Let's examine how the McGinty framework makes decisions. Traditional AI uses brute force computation or gradient descent, but HDO identifies optimal solutions through quantum resonance. HDO stands for harmonic-based decision optimization. This visualization shows a decision space with multiple potential solutions. As I increase the resonance level, watch how the system identifies resonant patterns that emerge naturally. See how the optimal solution is highlighted in red? This wasn't computed through iterative processing. It emerged through harmonic resonance, similar to how physical systems find their lowest energy states, or the PLA, which is the principle of least action. Now let's go to Module 5, Cognospheric Agents. In this module, we explore how intelligent agents operate within cognospheric space, or what I call C-space. Traditional AI agents process information linearly, but CAIAs operate across multiple dimensions simultaneously. The visualization shows agents represented as blue nodes moving through a multidimensional space. When I increase the fractal depth, or here, and the entanglement factor, watch how the connections form between the agents, enabling quantum resonant synchronization. This allows for decentralized intelligence that's greater than the sum of its parts. The agents share information not only through explicit messaging, but through quantum entanglement. Now let's look at Module 6, Quantum Resonance Cryptography. This final module demonstrates how the McGinty framework secures information through quantum resonance cryptography. The visualization shows data flowing between enterprise systems and being protected through QRC. When I activate quantum fractal processing mode, go here, you can see. When I activate quantum fractal processing mode, watch how the encryption key transforms from a static entry into a dynamic involving pattern. This represents how QRC eliminates static keys in favor of cryptographic states that evolve continuously through quantum dynamics, making traditional cryptanalysis impossible. What makes this learning system powerful is its interactivity. Users can adjust parameters like the fractal depth and controlling the complexity of self-similar structures, the harmonic resonance, which adjusts the quantum field intensity. The entanglement factor allows them to modify the quantum connection strength, and CSL mode, switching between classical and quantum fractal processing. Each of those adjustments provides immediate visual feedback, helping users develop intuition for what these abstract concepts do. Additionally, each module includes detailed explanations that connect the visualizations to the mathematical framework, helping users build a comprehensive understanding. The learning system serves multiple educational purposes. The first is a conceptual introduction. So for newcomers to quantum fractal AI, it provides an accessible entry point. And two, it's technical training for engineers and researchers. It helps build intuition for mathematical principles. And three, for enterprise demonstrations. So for business leaders, it illustrates the transformative potential of the framework. So by making these abstract concepts tangible through visualization and interaction, we're accelerating the adoption of quantum fractal intelligence across multiple different disciplines. The McGinty AI Quantum Fractal Intelligence Framework represents a paradigm shift in artificial intelligence, moving beyond neural networks and probabilistic models into quantum coherent multidimensional intelligence. This learning application makes these revolutionary concepts accessible, helping to build the next generation of AI researchers, engineers, and leaders who will bring quantum fractal intelligence to life. Thanks for your attention. I'm happy to answer any questions about the learning system or the McGinty framework.